me?
Yep.
Yes.
Okay. Okay, great. Sorry. Yeah. So this presentation is about demonstrating the feasibility of autonomous supply chains, mainly the coupling of agent-based systems and IoT systems and their application to supply chains. So just a very brief introduction to supply chains, because we've talked about this already quite a bit, so I'm not going to go into it in detail. But what is AI in supply chains, and how do agent-based systems differ from simulations, and where did we actually arrive? Why did we arrive at this particular conclusion that maybe agent-based systems might be a nice idea to couple with IoT and apply to supply chains? Okay, so in terms of supply chains, we have been talking, so Jorge mentioned this and then Angira mentioned this as well, but just as a reminder, organizations don't work in isolation. So an organization would be dependent on other organizations to produce a product or deliver a service to end users. And in manufacturing, we have in the recent decades, developed longer and longer and more complex supply chains, given we had moved into just-in-time manufacturing, modularization and standardization. For many companies, what that meant was reduction in barriers to entry, and as a result, a competitive supply chains developed where you have multiple organizations that you are buying the same stuff from, and then those organizations participating in multiple OEMs. So OEM stands for original equipment manufacturer, their supply chains. So if you think about a car which produces about 40,000 components and about 70% of those are outsourced, then looking at the supply chain, how can we make this efficient is really a big deal, as they also constitute about 65 to sometimes up to 80% of the final cost of production, especially in complex asset manufacturing space. So speaking of coordination and control, you'll see here a few complex networks that we have extracted from various different sectors, so namely automotive, aerospace, and FMCGs. And you can see that these tend to become at ecosystem level very large scale networks, and organizations embedded within this network can really only coordinate what it sees, and what it has power over coordinating, but that's another question. So these complex networks of interdependencies optimization is really a big word here. It doesn't really work, but what you can do in terms of coordination is to apply local techniques to try and maximize some sort of local team utility. So how can IoT and AI help us coordinate this type of distributed large-scale systems is the question we are trying to address here. So various tools of AI, including machine learning, have been proposed for predicting, prescribing supply chain operations in the past. And optimization is by far the biggest area in supply chains, which forms much of the field of operations research itself. But there's a disconnect there really, because as I mentioned, optimization is not possible at these large scales. So what we are trying to understand is how can intelligent agents, how can it be used to automate certain transactions, planning processes, and also encapsulate different prediction and optimization algorithms so that they can nudge the system to a little bit more optimal level. So what's an agent? So an agent is a computation system that's situated in some environment and it's capable of making flexible autonomous actions to meet its objectives. So intelligent agents are responsive to changes in their environment. They are proactive in the sense that you can give them goal-directed behavior and make them social so they can talk to and coordinate with other intelligent agents. So software agents are used in two different ways, traditionally in supply chains. So on the one hand, we have agent-based simulation, which is typically used to model bottom-up emergence and do what-if analysis in supply chains. And then we have the agent-based systems, where the main difference between the two is that in the systems, we do real things, whereas in simulation, agents are cut off from the real environment and they are being tested without the sort of particular nuances of the world. And that brings about different peculiarities to agent-based system design. So we need to, when we are designing an agent-based system to interact with real supply chain management systems, management information systems, you need to be worried about speed. You need to be worried about traceability of decisions, optimality of the decisions with the current data that an agent has, that it's giving a decision with, and also scalability of data storage and communication. So that particular viewpoint of, an agent-based system needs to interact with the real life is where we bring in IoT. So, so this is a framework that we developed for agent-based systems in supply chains. A zero intelligent agent would be a simple sort of monitoring agent where it's just really more attached to a sensor and is forwarding the sensor data to some platform. And if you included awareness to it, then you could, for example, ask it to do something when the sensor reading exceeds a certain threshold. That would then become a reactive agent with a bit of contextual awareness. So, and cognition then would be the next step. So after some things happened, it would know what to do. So for instance, if we're talking about a temperature reading in a truck, having reached a certain point, then it would tell this to the operator of the truck for the operator to do something. If it's, did something on its own, meaning it sort of controlled the temperature in some way, then it would be an autonomous system doing some action itself to proactively affect its environment. So now that kind of connection between the IoT and multi-agent systems was sort of, it had brought us to 10 years ago, a study that we have done with Boeing, which we called self-serving assets in a highly networked environment. So the motivation behind this was service and maintenance. Boeing was moving into condition-based monitoring for some of its aircrafts, and we were wondering whether we could automate some of those supply chain automations that surround condition-based monitoring, such as selecting suppliers, ordering from suppliers, and then negotiating batch quantity discounts and so on, because lots of procurement officer effort was going into these mundane tasks. So what we were trying to do is to understand which asset was expiring or having its health degraded, and then it would connect to other assets in the aircraft or across aircrafts to try and understand which other assets are facing similar situations so that you could place batch orders to suppliers automatically. And the main focus here was around trying to create an architecture that was scalable and persistent to failures. At that time, 10 years ago, when we did, we ended up using an open source DARPA developed software system there called Cougar, which doesn't exist anymore. But really the main point there was that IoT systems weren't very widely sort of available. The sort of agent-based systems were even less optimal. They were clunky, most code was abandoned, and there was no ready connection with sensor systems. And very importantly, security was not very well handled in those cases. 10 years on, we have started this project in Pichin, which again tries to rekindle those efforts and see what is the current state of joining IoT and multi-agent systems, and could we develop really a feasible, scalable automation system here. So we are working on this problem so it's a toy problem. Based on real life. So we have a company that's selling some sort of perishable food product, and it purchases this product wholesale and then supplies to local restaurants. So it wants to procure meat from its suppliers, and then tries to order from suppliers, and then what it wants to do is that when those suppliers are tasking other logistics providers, and those logistics providers are tasking other logistics, third-party logistics providers with the delivery to the retailer, what the manufacturer wants to do is to be able to understand the condition that the product was in throughout the delivery chain, so that the manufacturer can actually guarantee to the retailer that the product is safe for consumption. So that is our toy problem. And we have developed our first demonstrator using Fetch AI's. So Fetch AI is a local Cambridge AI startup company, which primarily tries to design agent-based systems for transactions, so for automating transactions on the blockchain. And their platform really addresses some of those concerns I have mentioned earlier in terms of code optimality and security. So we partnered up with them to develop this. And here we have got 5 different types of agents, which represent different actors in the chain. And if you go back to our framework, what we are really sensing is humidity and temperature. Then in terms of awareness, what we want to do is to be able to understand, to be able to be aware of what the product condition was, and then so that we can finally predict the product quality. In terms of autonomy, the only autonomous bit that we are really working on is the selection of bids and triggering of the procurement process, which happens automatically in the platform. I won't go through this given time constraints, but this is generally the framework that we are working with, where we have a Google-like kind of interaction where agents can find each other and start communicating with each other. That makes this agent-to-agent interaction representing different organizations possible. We are also not using this smart ledger layer in the Fetch AI view of the world, just because we didn't want to go into that for this particular project, but it's nice to know that it exists and transactions can actually be carried on in this layer. Okay, so this is just a screenshot of our current demonstrator, and if you want to sort of hang around after the Q&A session, Liming is very happy to show you how it all works. Yeah, so just if you don't have time, so here we have got an ordering panel where we are placing to buy products. Then here we are visualizing the real-time track and trace of transportation. And on the agent chat room, you see the negotiation process among the agents. And here we see the data streaming, on which we can continue doing some analytics. Okay, I think this is the last slide. So yeah, that's in a nutshell what we are trying to do. It seems, so our early conclusions really, although the project is far from its end, are that agent systems have become more robust, and they give rise to these exciting opportunities in supply chains, particularly for coupling IoT-based data streams into supply chain information systems. But explainability and the acceptance of this decentralized data sharing remains a challenge. So I think further projects will focus on that. And with that, I'm stopping my screen share so I can see you guys. Right, so everyone's still here. Any questions?
I've got a question, Alex.
Yeah.
And I know this from experience. You mentioned one of your slides, you talked about the fact that delays and quality control issues were an issue in the real world. And I know that from bitter experience, having to explain to customers why, because our company hasn't delivered on time, has been a problem, as does my wife. She does that every day, and so I hear her conversations quite often here. So my question is, given that these things do happen down the supply chain, tier 3, even tier 1, tier 2, tier 3, how does your model account for that? Do you just put in a figure that you've derived empirically? For example, I don't know, 25% of all products are going to be delayed by 2 weeks. Or how do you account for that in your model?
Good question. We didn't is the answer. So we didn't go as far as planning for particular companies and optimizing their inventory levels. It could be done, but really what we are providing in this particular project is a shell to make data transfer happen. And that data transfer could be one company saying to another, hey, I am running into problems, I'm late. Or it could be an agent optimizing.
And I guess the difficulty is, coming back to the conversation we had earlier about just in time, what have you, is that some components are mission critical. It can be a 40-pound component in the car and holds up the entire production of the car. So I think it's a difficult problem to crack, but I think it's an important one for the model to be workable as you develop it. Obviously, as you say, you made the shell. So yeah, just that point. Thank you.
Thank you. Thanks, David.
I also have a question, if I may.
Yeah.
Thank you very much. I very much enjoyed your presentation. So my question is in terms of the feedback that may have been provided to Fetch AI based on your collaboration, whether they may have introduced new features into their software, or how did the collaboration work, and whether they working with you has made them perhaps reconsider some of the features of the software.
I think I will pass that question on to Liming, because he's been the main sort of developer of the platform and also the brain behind all this. Yeah.
Okay, thank you. Thank you for questions. I think like Fetch AI is keeping developing update the technologies. I think like probably the performance of the bottom layer, like the Fetch AI layer. And I think they also add new features to the interface layer, like the AEA, the framework is directly used for developing some agent-based system, use that framework. And this current demo is used, I think it's the third version, and the latest version has been, I think, reached for the version 6. And they have actually added some up greatly. I think largely changed the framework and made the development more easy to use, I think. And also, I'm not sure, like currently they can develop each agent, like just use very old version of feature AI, and I haven't go read through the latest version, and just some quick read through of their documents. I think it's have great improve their technologies, and I think it should be more easy to development, and also it can support Python and some machine learning packages, libraries. So it can support like some agent and AI based systems. Yeah.
Thank you.